Hi everybody, good to see you guys again. I just wanted to talk a little bit today about our discussion about blood and the cardiovascular system. I know you've been doing a lot of work on your homework, so hopefully this is really starting to stick in your mind, but I wanted to just go through the blood types really fast just to make sure that you hear it from me as well. So our red blood cells have antigens on their surface, and an antigen is simply, as far as we're concerned, just a shape on the outside of the cell. Sometimes it can be a protein, sometimes it can be a particular sugar, but these are markers or identifying markers on the outside of our cells. And we have these on all of our cells, but in particular we have them on our red blood cells, and that's what ends up being the defining factor to determine what our blood type is. So in this example, the A antigen is simply this circular shape on the outside of the red blood cell. The B antigen is this triangular shape. And those are the only two antigens possible as related to these ABO blood types. Type AB is not an AB antigen. It's not a square, right, as a third shape. What it is a combination of both A and B scattered around the surface of the cells. And if somebody is type O, then they have no antigens on the surface. It's not that they have an O antigen, it's that there are neither A nor B antigens on the surface. You can think of a type O red blood cell as being a naked red blood cell like you see here in this picture. The other piece we need to talk about in regards to red blood cells is the presence of these antibodies. These are small proteins that are used by our immune system. They are specifically produced by type B lymphocytes, and these proteins are used to tag cells, particularly foreign cells, for destruction in our body. The antibodies are able to bind to their matching antigen. When they do that, it activates a series of events that ensures that that cell that they're bound to gets destroyed and swept out of the body. So the important thing to know is that between an antibody and an antigen, there has to be a specific binding. And that binding can only happen, just like we've talked about with other receptors, that binding can only happen if there is an exact shape match or an exact antigen match. So in this case, an A antigen would only be able to bind to an anti-A antibody because the shape matches the surface of the antigen, right? The type B antibody, the anti-B antibody, would only be able to bind to, actually it would be like that, would only be able to bind to the type B antigen. Okay? Now, let me erase this really quick so I don't get everything looking so cluttered. There we go. The interesting thing is that in our bodies, we typically only produce antibodies when we've been exposed to some type of foreign antigen. That's why we end up being sick at first, like when we get a cold. We have a cold virus that makes its way into our body. Our body starts to fight off that cold virus, but it takes about 7 to 10 days for antibodies to be produced that can attack that cold virus, and then we notice that our symptoms disappear. The interesting thing with these ABO blood types is that these anti-B and anti-A antibodies are pre-made. They are already circulating in the plasma of our blood. So these particular antibodies don't have to we don't have to be exposed the first time in order to produce these. So that's a really handy thing, because that allows and makes sure that we can actually fight off and kill off any of these foreign blood cells that make their way into our bloodstream without having to deal with the adverse effects for that 7 to 10 day period. So really quick, just to make sure you're all on the same page with me, somebody that has type A blood automatically has anti-A antibodies because A is the familiar antigen. It's what they already have. B would be the unfamiliar antigen. This would be the foreign one. So familiar antigens are great. So we wouldn't have an anti-A antibody in a type A person because that would actually agglutinate all of our own blood cells, and that would be a problem. So if we're type A, we have anti-B antibodies in our bloodstream. If we're type B, we have the opposite. We have anti-A antibodies because the A antigen is foreign. If we have type AB blood, we have neither A nor B because both, in this case, are familiar. Both are supposed to be there on our cells, so if they show up on somebody else's cell that's in our body, we don't care. If we are type O blood, that means, remember, we have this naked cell, so both A and B are foreign. So we have to have anti-A and anti-B antibodies in our bloodstream to make sure that we can protect against both types of antigens.